Okay, so the stage
You
is
also
yours.
have a pointer.
We have a
one?
pointer
Yeah,
here.
perfect. Is it possible to point with it as well, or is it just to switch?
You can point with,
Yeah, perfect. Okay, thank you for this opportunity to talk about the twin green and digital transition of the process industry. As mentioned, I'm Håvard Moe. I'm SVP of Technology in Elkem, but I've also been leading as the chairman of the board of Process21, which is a governmental initiative to see how explore how the process industry can take a leading role in the green transition. My presentation today consists of four main elements. I'm going to give a very short introduction to Process21, just to tell you what this is. I will spend approximately 25 minutes on some perspectives on the process industry. Basically, the process industry in the future will be regional, and it will be climate neutral. And then I will try to link what is happening in the process industry with digital. I think that's why I was asked to come here to talk about the link between process and digital. And then some concluding remarks at the end. Process21 was launched by the government in 2017 by the Norwegian Conservative Party. We were given the mandate to give strategic advice on how the process industry in Norway can take a leading role in the transition into low greenhouse gas emission society. We delivered several advices in 2020 and 2021, and we were quite happy to see that several of these advices were included in the agreement between NHO and LO in 2021 as a basis for the industry collaboration between the employers' organizations and the employee organization. We delivered the main report to the Prime Minister in February 2021. And last year we had a kickoff meeting with the new Minister of Trade and Industry, Mr. Jan Christian Vestre from the Labour Party. And that's something I think is nice, is that we have now been delivering both to the Conservative side and to the Labour Party. So, process industry. What we're talking about is really how will the European Green Deal, the transition to a net zero society, affect the process industry, or how can the process industry contribute? I'm not sure how many of you who have looked into what this is, but this is probably the biggest change in society since the industrial revolutions. We're talking about the complete change of how we're going to make our products. It's a full systemic change, so it's not like what happened 20, 30, 40 years ago when we started to clean what's going out of the pipes or starting to automate the production. It's about the complete change of society. And that's what you see with the European Green Deal. Of course, we have zero pollution, we have carbon neutrality, but we're looking now, linking farms to fork. I mean, taking agriculture as a part of the total value chain. We have the requirement for circularity, which is probably not going to support climate. It's going to require more resources because it's more expensive to upgrade than to use products than to take virgin materials. So that's a change. A huge change in the energy system. And at the same time, the EU Commission has taken a political role and saying that, well, no individual should fall behind, because there are big differences when you do this change, because energy will become more expensive in some places. We will have a big transition away from coal. And how are we going to make sure that the people that today are working on coal production and producing the cars of yesterday, the yesterday cars, and not the cars of tomorrow, they need jobs? Because we don't want Europe to develop as we have seen in parts of the US, where we have a tendency to social unrest because people then don't have the expected standard of living. So this is a huge, I will say, social experiment. and this is going to be done because Europe would like to cut only 10% of the world's CO2 emissions. And assuming that this is the right thing to do, which I support, and then hoping that 90% will be taken by somebody else because China, US, and others find out that this is the right thing to do. So it's a big challenge. It's going to be very interesting to work on this until I retire sometime 15, 20 years into the future. So I will talk about the CBAM, talking about an example from the steel industry, critical raw materials, decarbonization of the silicon industry, touch upon hydrogen and e-fuel. That's impossible not to talk about when talking about the green transition, and then access to renewable energy. CBAM. This is a system that is supposed to put the fair price on carbon emitted during production, and it will cover imports of material or certain products into European Union to avoid carbon leakage. We're talking about cement, iron and steel, aluminium, fertilizer, electricity, and hydrogen. And this covers approximately 50% of the emissions from the industry covered by ETS. It will be started in October in a transitional phase, and it will be fully implemented by 2026. I would not talk too much about my opinion about this. I think this is really exciting, but I see a lot of pitfalls. And it will probably, what we will see is that this is something we will try to adapt to, and then it will most probably be modified during this transitional phase before it's hopefully going to work in 2026. But the main principle that we need to take into account or act according to is that we have to change the way we produce certain material in Europe, certain products, and that there will be systems in place to avoid carbon leakage, meaning that we'll have a reindustrialization of Europe. And one company that has taken that really seriously is ThyssenKrupp. ThyssenKrupp is now going to build a new steel plant. They have placed the order to SMS alone of order 1.8 billion euros. That's 18 billion Norwegian kroners to decarbonize steel production in one plant. And they're going to cut, by doing this, they will produce 2.5 million metric tons of directly reduced iron, and they will have a saving of 3.5 million metric tons of CO2. If you look at the ferroalloy industry that I'm following, Elkem and Eramet, we are quite similar. This will be approximately, we have in total in Norway, I think we are emitting 2 million tons together. That's 4% of the Norwegian CO2 emissions. And what ThyssenKrupp is going to do is to take almost twice as much in reductions in one project. So that's quite inspiring. Talking about something that's smaller, but important for at least me and some others in the audience is silicon. The European Commission has proposed a European Critical Raw Materials Act, including a list of 16 strategic and 34 critical raw materials. The strategic raw materials are important for the green and digital transition, as well as defense and space. And then you have 34 that are critical, which are important for the EU economy, and there is a certain level of supply risk. And this list has been increased, not year on year, but I think this is the 5th update. The last time I gave this presentation, there were 30 critical raw materials, and before that there were less, but being in Elkem, silicon has been on that list for quite a long time, so we think that's important. It's something that Europe needs. And you know, I mean, silicon, it's silicium. Silicon Valley, it tells you a little bit about the importance. It's important for solar, it's important for alloys, for wind turbines, it's important for silicones, and it's important for aluminum. So in Elkem, we have established a climate strategy. We published a strategy in 2021 with a target of reducing our absolute emissions by 28% by 2031. And we're planning to grow at the same time. So our product footprint, meaning the CO2 footprint per ton of product, will be reduced by 39% during the strategy period. And we are now in the third year, and we are delivering on footprint reductions, which is we're quite happy according to a linear decline or reduction. We are not fully delivering on our absolute emissions because we are increasing. I mean, we didn't take into account that we will grow the business as much as we have done, so now we have to take some extra actions to reduce also the absolute emissions, but quite on track on the product footprint. And our target is to be fully carbon neutral in 2050. And you mentioned 2040. I think we will probably go to 2045 because this industry will be a little bit behind steel. It will be behind transport, but it has to be in front of some of the other industries that need to be at zero at 2050. We are, of course, doing what we can do with traditional measures towards 2031, and then we are exploring CCS and some alternative technologies. And that's what I'm going to talk about now. We're running a pilot on CCS, the first CCS capture plant on this kind of production process. We're doing a pilot in Rana together with Moe Industrial Park and Aker, with a lot of support from Gassnova. It's working quite well. We're taking off gas. It's a very small pipe compared to what you will see on a smelter. Usually a flue gas pipe would be like 2 meters, so you can stand in it. This is a little bit smaller, but it goes into a process container, and then we have the absorber, and then we have the desorber. And we're getting a lot of good information now for the design basis for a full-scale plant. So that's something we're looking into. Technically, it's going to work. And that's not a surprise. My first job was as a newly graduated engineer was in 1996, being part of the startup team at Sleipner West, the carbon capture plant. So I mean, we succeeded somehow in the 1990s. So why shouldn't we shouldn't work in 2023? The big challenge here is really the investment cost. If we would like to build a smelter today, and we added on carbon capture, that would increase the capex by a factor of 100 or add 100% to the investment cost. So it's not for free. But I mean, if somebody is willing to pay for CO2-free products, then we can do it. As it is now, we don't get paid for it, so we will not do it. But if somebody will pay, then we can do it. We also look into to capture bio, because we have a lot of bio CO2 in our off gas. And we're talking then about negative emissions, and we're looking also into how we can convert CO2 into methanol and use the CO2 at least once more. That would be like one circle. That would reduce the CO2 emissions in total by 50%. We don't think the carbon capture is the end solution. It could be a midterm solution. We believe that you need to not have an end-of-pipe solution. You need to have something where you're not really emitting CO2. So what we have done now is to take it one step further, where we take the CO2 from the carbon oxides, monoxide and dioxides from silicon production process. Then look at how we can recycle the carbon, take the CO2, take hydrogen in, and then get carbon out and then use that for the production process. So we're just recycling carbon. It's working quite well at lab scale. We have quite a big project going on now at SINTEF and in Kristiansand. We are testing now this process at the lab scale and bench scale. And we are in a process of preparing both for a scale-up with support from Enova, hoping that will work. We'll agree with Enova, and then we're also looking into finding partners for an EU project to scale up. A lot of good support from SINTEF on this project. So ThyssenKrupp is planning to use hydrogen. Elkem is planning to use hydrogen. A lot of others are talking about hydrogen. And that's the difficulty. You can get it from electrolysis. You can get it from natural gas. You could also use coal to produce hydrogen. The challenge is that it's very energy demanding to produce hydrogen. And if you use Yara as an example, if they are going to go away from natural gas to electrolyzers, we're talking about increased consumption of 4 terawatt-hours per year in energy. You're for Yara, so maybe that's correct. Elkem, Norway is producing hydropower between 125 and 140 terawatt-hours per year. So we're talking about a huge part of the Norwegian power consumption just for Yara. And even more important is that to transport that electricity, I mean, Sverre said that Hydro solved that 100 years ago, but we're not able at the moment to transport that amount of electricity into Herøya to produce the hydrogen Yara needs. And it will be the same for Elkem's smelters. So we're talking about developing of the power grid, which is a quite time-consuming process in Norway at the moment. And then e-fuels, I mentioned e-fuels, we're looking into converting CO2 into e-fuels. From an energy perspective, it's challenging. If we would like to reuse 2% of the Norwegian CO2, that's 1 million tons. As methanol, it will require 5 terawatt-hour electric power. So e-fuel projects in the north of Norway, if you look at some of the announced ambitions, that will eat up the power surplus or in northern Norway very quickly. In NO4, we have some say 5, some say 8 terawatt-hours per year available. So if Equinor and Elkem and some of the others chose to convert that into methanol, that will create a big undersupply of electric power in the north of Norway. So going back to what Sverre mentioned, renewable energy. This green transition is not only a green transition, it's an energy transition. EU in 2021, 22% of the gross final energy consumed was from renewables. And then EU has a target of 32% in 2030. We got some insights in what this will mean when you look at the war in Ukraine and the stop of natural gas exports from Russia to EU. That showed us the vulnerability of the power system in Europe, with very high power prices and also discussions about cutting back on power consumptions, people turning down the temperature in their offices in Central Europe. And we had this discussion in the Norwegian industry, the Confederation of Norwegian Industries, about a potential cap on production from the process industry because of undersupply of electric power in Norway. So that's some of the challenges. We will see if we have an undersupply of energy, and then we got the stress test with the war in Ukraine. One of the challenges with renewables is that they're not stable. Renewables are stable in Norway because we use hydropower. Renewables are not stable when you use solar and you use wind. I installed the solar panels on my garage 3 years ago to learn a little bit about this. It's always more, you learn more when you see it on your in your home and on your paycheck or in your in the bills, the power bills you get from the local power company. And what I think is interesting is my solar panels. They are producing a lot of power. Last week they did, but I didn't get any. I mean, I could get the power for free from the grid because the power price was zero several days when the sun was shining in Norway last week. And we see the same when the wind is blowing in Central Europe. You can get power at very low cost in southern Norway. And this week we had a zero power price in the north of Norway because of a lot of snow smelting. So then we see that the power price was 1.5 euro in northern Norway this week. So that's a little bit of a challenge, and that's where we are. We're facing probably a power a negative energy balance. That's forecast, and then we are seeing big variations in power price. This is, I was not surprised when Statkraft published this one. It's very much in line with what Process21 published 1 year before about the need for renewable power. The nice thing about Statkraft is that it was based on more facts than we had in Process21, and it was also showing a little bit more short term. We looked at 2030 and 2050. What they did, they looked at 2027, which is quite near, only 5 years from now. And we're talking about a negative energy balance of 7 terawatt hours, meaning that we're going to have a lot of power imports from Europe. And that means that we're going to import the prices also from Central Europe. And you see these power prices on a weekly average. If you made the same graph with, I was trying to do that with a download from Nord Pool on hourly basis, but I was not able to make very nice, very nice graph. But then you see really big peaks. So how are we going to deal with this? And that's where the digital part comes in. So we have a lot of challenges. They're complex. And it should be possible to get access to data. And when you have access to data and you have a challenging problem, then we're talking about digital. That's when you have the opportunity to use digital solutions. On digital, and if you see here, the reason why some of these are with Process21 and some with Elkem is the old ones are with Process21 and the new ones are with Elkem. That's hopefully we'll have some more on Process21 when we have more expertise. But this is an old one from the expert group on digital in Process21, looking at some of the global industrial front runners. This is from BASF. They have a very good digital strategy, focusing on business models, supply chain, innovation, and manufacturing. And they have put numbers on their ambitions using digital to improve profitability, both front end with customers and more on back office. This one, I also like this one, is from McKinsey. It says something about where you can get benefits from implement digital in different industries. And what's nice about this table or illustration, it shows that the size is illustrating the benefit. And what they've done, they have looked at the characteristics of mining, chemicals, petrochemicals, and so on, and see where can you use digital. In mining extraction, a lot of work, manual work or work with machines. Then we're talking about robotics. In chemicals, it's really about getting as much as you can out of the investment. It's about throughput. They didn't have downstream chemicals where we're talking about cycle times and the quality of products and the ability to optimize sequence and manage a huge amount of customers. That's something we work in Elkem with. We have like 3,000 different silicones products, and we're trying to optimize this the willingness to pay to where we sell using the production facilities. That's a really nice optimization task. So that's where you use digital. But linking digital and green, how do you do that? I was thinking about what I should say, and then I Googled. That's always good. You Google, and then you find out somebody has already written a report, so you don't have to invent that yourself. So take this one, download it. You have the link here. A lot of good stuff in that report. So it tells you a little bit about the future. But what can you learn from this? Well, it covers steel, cement, chemicals, and pulp and paper. Steel, 12% of the global CO2 emissions. Cement, 8%. So it's like 60% of the emissions from the industry, steel and cement. We have cement in Norway. We don't have much steel production in Norway. We have a lot of chemicals. And then we have other metals like aluminum and silicon, which also contribute. Carbon capture, and I mentioned ThyssenKrupp with hydrogen. Cement, carbon capture, hydrogen, and alternative chemistries. Chemicals, talking about circular and alternative production process. And then you should get rid of this one because I could say something about pulp and paper, but it's about electrification. Very similar, even though the industries are quite different. So how can the green and the digital transitions mutually reinforce each other? So you have the digital part, and you have the process industry part. And the process industry, what are we doing? I showed you an alternative production route for silicon, or at least a modification of the silicon production process. If you want to do something chemical, it's about catalysts. And if you would like to have higher resource efficiency, you need to work more on how you actually get better yields on energy and other raw material inputs. And we're talking about renewable energy. And then on digital is contributing a lot to the green transition. If you look at more service-oriented companies, we're talking about digital remote working, digital services. E-commerce is, of course, helping us on the sales side. Automated administrative work process, that's something when we got the new CEO in Elkem in 2019, I think, was it? Yeah, it's the German guy that was with us for 19 months. He the first thing he did was go into our company and say, well, you're really a lagger because you don't have fully automated your administrative processes. Saying, how can we cut cost above plant by automating our administrative processes? It's important, but it doesn't contribute that much to this green transition. It helps on cost. What we're looking at, what kind of digital technologies, and that's really, I think, what you're interested in. What kind of digital technologies do we need to support this green transition? Data-driven raw material energy optimization, powerful intelligent online sensors are quite obvious. If you look at the top 5 challenges, first of all, the energy market will be completely different 10 years from now than what you see today. So the ability to optimize capacity utilization, energy sales, energy purchase, that's really a key skill we need to have both for the existing processes and for the new processes. Elkem is doing this all the time. I'm sure Eramet is doing this. Yara, deciding when to produce and when to sell. I mean, we buy power on long-term contracts, and then sometimes it's actually better to sell that power back than to produce what we're supposed to produce. And sometimes we're announcing that with press releases that we're chosen to shut down because we sell the power. But there are big opportunities to do this more short-term, taking into process dynamics. Okay, and then we go to next generation of production processes. They will not be the same as we have today. if we would like to really be profitable in a very volatile, first of all, if we would like to build, we need to get low capex. If not, we will not be able to build. It will be built somewhere else where you can build at a lower cost. So if we are not able to make high intensity, more low capex production processes, we will not build. And then when we have made that, we need to have really advanced systems where we integrate this with the low capex, high intensity processes with the energy. I think that's going to be a game changer. And that's really high on the agenda for our process development of the new silicon process. And then the new production processes, we will produce new products and materials with existing new products and materials with existing production processes, or we will produce existing products and materials with new operating conditions, or we'll do both. Meaning that the sensors we're using today, we don't have the sensors we need for the future. So sensor development is really important, and that's something you cannot really buy from the market. You can do this together with sensor research institutes, with companies providing sensors, but in most cases you need to do that based on your insight of your process and your operating conditions. And the strategy at Elkem is to have a good knowledge about this. This is really an important area for us, and then see how we can be part of that development, and then get somebody else to produce the sensors and sell them to others. Because we need a certain volume, we need service on these sensors, and we're not big enough to do that ourselves. If we were ThyssenKrupp, maybe we could do it, but not as a small company as we are. So this is really important for the smaller companies. Circularity and no waste is a no-brainer, and to be able to work on circularity, we will take in. One thing is tracing, but you get a lot of stuff back. It sounds nice, but that is circular, but this is really a lot of waste that you get with a lot of impurities. So to identify and see what's coming into your process, categorize the new raw materials, which is a much broader range. So we're talking about the broad range of raw materials into new production processes. That's quite good to be an engineer now, because we have a lot of challenges to solve. And then the last part is on the IT, OT, cybersecurity, really key. There are good standards in place, and the first thing we need to do is to implement those standards on the existing facilities, and then make sure that the standards are keeping up with the new requirements we have from our production processes. That's the perspectives from somebody with a more operational background on digital. And then the additional soft challenge is that we are probably not the most attractive company to start working in. Yes? Yeah. Mm. Yeah. Yeah. Mm. Yeah. Yeah, absolutely. Yeah, it's a hard, but it's a people challenge. It's not technical. Yeah, yeah. And I think we are not using the momentum of the European Green Deal in our communication. We had a discussion yesterday in corporate management about our communication strategy, and it's quite looking back into the past. And that's quite natural, because it's made by old people and they like to look back in the past. But if you look at the European Green Deal and look at the ambition level, I think we should, as an industry, be much more ambitious. We're talking about making something that's going to substantially change the future, and we're not communicating that. And then why should people work for us if we're not being part of the future solution? So I think that's where we should start. Because we're talking about from a technical point of view, probably the most interesting you can do now. This is much more interesting than what I got the opportunity to do 20, 30 years ago when I started, because the transition is so much bigger. Yeah. Okay, so concluding remarks. there are big ambitions in the European Union. And some European frontrunners, I was not very modest when I said ThyssenKrupp and Elkem in the same, because we're talking about like a factor of 100 between what they're doing and what we are doing at the moment. But at least we have ambitions also in the company I'm representing. Some companies are developing and deploying novel production processes for carbon neutral or no greenhouse gas emission production of their main products. We are to do this transition, we are strongly dependent on both utilization of existing and develop on new digital technologies. And I think with the tradition we have in Norway, in chemical engineering and engineering cybernetics, in combination with quite a good digital penetration in general in the society, we should be well positioned to have maybe not a leading role, but at least not be a laggard in this area when we're talking about industry development in Norway. So the biggest challenge I see is actually access to renewable power. That's the biggest challenge. The rest we should be able to solve within the community. Okay, I think my time is almost. I have 4 minutes for
Yes, thanks a lot.
Questions.
You have okay. So we do have some time for questions or thoughts on Håvard's ideas. Frode?
What are your thoughts about the nuclear power? You mentioned that the new
No, I think nuclear power will be part of the future power mix. I mean, it is in France. It is in the Nordic power mix. It's a debate in Norway, but I mean, we're part of a Nordic power system, and we see that the power price is going up when the nuclear power plants in the Nordic countries are taken out for service. So they're definitely part of the picture. I think it will be necessary to stabilize the power grid in the future. Because you will have so much renewables and you need something to produce the base load. I'm not sure that hydropower is enough. That's my personal opinion. And then there's a question if Norway should have power plants. I don't know. I mean, if you build one in Halden, I mean, that's a big one that could help. But if you build it outside Göteborg, it doesn't matter too much because the connections are not that bad. So, but I think this is something the politicians should look into, but they will not solve the challenge in 2027 with lack of 7 terawatt-hours per year in southern Norway. But I'm convinced it will be part of the future power mix. Okay. You had a question?
slide on where green transition and digitalization meet and can reinforce each other. You mentioned data-driven raw material and energy optimization. But for metal production, those energy-consuming processes are continuous, and then they take time to change the energy structure. I was just wondering if you can elaborate a little bit on where you see the opportunity for that.
Yeah, I can do that. I started Elkem in 2008, and I asked some of the leading scientists on the silicon yield. And they say, well, 84 is theoretical maximum. And I was not a metallurgist. I'm still not a metallurgist, and I didn't believe them, but nobody could say something differently. And now we're producing silicon at a yield above 90% because we are using digital solutions. So that's more like lifting the bar. If we are going into more high intensity processes with more rapid dynamics, then the optimization will be combined optimization of raw materials and energy. I think that's going to be quite an interesting one. So to be able to maximize the yield when that's the right thing to do, and sometimes you would maybe not want to maximize the yield because there are other financial drivers that you would like to maximize on. So that's where I'm seeing it from. And I don't think that's possible without having data-driven models, because your first principle models are not good enough, especially in metallurgy, but also in some of the other processes. You're basically not able to describe it on an algorithm without using at least a Kalman filter or some other stuff to take the data into account.
But you don't see any opportunities for you're optimizing with the energy prices, the price market.
Yeah, that's yeah, we do that today. I mean, we have in some locations we have to reduce production 4 hours per day because of the peak demand in that region. We're doing that quite simplistically. We just turn off the power for 4 hours. I'm sure there are opportunities to make that a little bit more intelligent if we had good models. So, and you can imagine if we bought the battery pack and we were able to smoothen out that ramp up and ramp down by having like a small accumulator in the system, I'm convinced that that could pay off, but we haven't done it yet. We need some smart guys or girls or people that could do that. Yeah. So there are a lot of opportunities. Yeah, we are working on the things that we can control 100%, and then we'll let other people work on things they can control. So that's why instrumentation is for me the most important one, because that's closest to our core business. Really to understand what's happening in our production process and make that digital. Put it that way. I get the physics. I think that's the most important for a company like us. And then looking at this combined optimization of power and production process, we will provide the characteristics of the process, but I'm sure we're going to do that with somebody else because that's like a more systemic or from a system side where this challenge will be similar in different industries. So it's still important, probably with the highest value, but it will not be where we're putting all our resources, because this is something we will probably get better if we buy it from somebody with experience. But really to make a data representation of the physical system is really should be core competency of any industrial company. Yeah. Mm-hmm.
Using CO2 from your own process.
Yeah. No, we create reduction material, not anodes. We use it slightly differently. It's not, yeah. And then when you get that carbon out of the CO2, but because basically that you recycle carbon, it's to get the right structure of that carbon, because and that will be different for different processes, because the carbon you use is different, or your carbon source is different in different processes. So there's a lot of chemistry in that part, which will be different for different companies. Okay, good.
Thanks a lot. Okay, so you also have the opportunity to give a gift.
Yeah,
thank you. Thanks a lot.
Yeah.
Now we have a small